So thank you very much for being here and welcome to this startup pitch session for our Global Construction Tech program. So I think we can start. There are still some participants that will arrive, but I suggest you to begin. So we are glad to have you here with us today to talk about energy. Just to give you an overview about the participants and the audience of today, we have different kind of industry leaders in construction material, contractors, engineering firm, and CVCs that are with us today. We can present you and say that there are members from companies from all over the world, such as Shimizu from Japan, Gulermak from Turkey, Shibumi International from United Arab Emirates, Fundamental from Germany, and CRH from Spain, Ferrovial from construction. So a lot of international actors. And we are really glad to gather people from all over the world to talk about energy and such an interesting topics. And throughout this session, our ambitions at Impulse Partner is to provide you an international overview of innovation and how tech is developing in construction and beyond. And today, so particular, we are, as I was saying, we are talking about energy. And for sure, it's not so easy. And before to start, we would like to give also our vision about the energy ecosystem. It's not so easy to give a complete overview about this huge sector with a huge implication at different level, but we would like to give you just some kind of overview and synthesis of our vision. We have different kind of actors that take part to the energy ecosystem, that are the energy producers, the network managers, and the users. And for all these kind of actors, we have identified different roles, scopes, and application, such as the producing and the processing for the producers, the conversion and storage and distribution for the network managers, and the local production, performance, and consumptions and recovery for users. So, of course, we cannot we have to consider also the local authorities as part of this ecosystem, and their role is to encourage the production policies of the actors in their territories, and also to allow the improvement and growth of opportunity through public investments, and also to allow the private investment and financing to encourage the growth of the markets and the growth of opportunities. So after this little introduction, I let the stage to my colleague Zineb in order to introduce you the participants and the startup of today.
Thank you so much, Alice. So today we have the pleasure to welcome Nicolas Lebogne, who will present Thermosphere first, a plug-and-play solution that allows to manage in real time the HVAC system, so heating, ventilation, and air conditioning. Then Michael will present Friltech, a startup which designs the vacuum capacitor, an innovation in electrical energy storage to overcome the current limitations in e-mobility and stationary storage. Then Richard Wise will present Polysolar, which develops, designs, and installs project managers, building integrated photovoltaic solutions. And finally, Michael Evans will present Cambridge Carbon Capture, which is a startup which has developed the CO2 LOC technology to sequester CO2 in the form of rock, which can be used as a byproduct through a mineralization process. Thank you so much to our entrepreneurs to be here with us. Thanks to the audience. And I think that this session will be very insightful. So Nicolas, the floor is yours for the presentation of Thermosphere.
Thank you, Zineb, and thank you, Alice, for the presentation. Glad to be here, and thank you for welcoming me. So I'm Nicolas, CEO and co-founder of Thermosphere. I will present you briefly our solution for software solution for the optimization of HVAC systems. You can move on, Zineb. So what we propose at Thermosphere is a pretty unique solution using only SaaS, so only software, no hardware, to improve the energy efficiency in the operations of heating, ventilation, and air conditioning in commercial real estate. Please move to the next slide. So what we deliver at Thermosphere is some kind of a turnkey solution. Our goal is to make it as simple and as quick and efficient as possible for property managers, facility managers to improve the footprint of their building, whether it's on the energy side, the CO2 side, but of course also on the cost side. So what we actually deliver is a real-time solution to control the HVAC equipment. And this means that we remotely do the same job as a building management system by adjusting set points, by adjusting schedules and statuses of the equipment. And we use a technology that we have developed in-house at Thermosphere, which is thermal modeling on the one hand and model predictive control on the other hand, and I will tell you a little bit more in a bit about that. So the way Thermosphere works is basically three steps. First, of course, is the installation. As you know, buildings are all very different, and especially when it comes to building management systems. That being said, with Thermosphere, we have a solution which is agnostic, whether it's on the brand model of your BMS. We can connect pretty much to any building and optimize HVAC in any building equipped with a building management system. The second part is the maintenance itself. We're also aware that using new tools can be confusing and very time consuming for the team. So what we deliver again is real-time control and monitoring, meaning that everything is kind of happening behind the curtain. It doesn't require any involvement or participation, active participation of the technical teams on site. We basically take care of the optimization ourselves, and you just have to see the results and the good numbers that result from it. The last point is the return on investment. As I mentioned, we can deploy our solution extremely quick. We aim for 2 to 3 weeks on average to start seeing the first results of our optimization. And the good part of it is that there is no CapEx involved. So you basically only get the savings without having the risk or the exposure of having to invest in replacing equipment or installing new hardware in the building. And we aim on average for a 30% cut on your energy cost. In other words, starting in month 1, you already get the return on investment from the Thermosphere. Can you move to the next one, please? Thank you. So how it works very concretely, we've tried here to summarize the Thermosphere solution. So I think you all have this vision of a building space where HVAC equipment is installed, and this HVAC is more or less controlled by BMS schedules and rules. The way we deploy Thermosphere is by connecting to the network of the building management system and directly communicating with the HVAC equipment. So whether it's boilers, chillers, air handling units, ventilators, but also sensors. And that results in us installing a gateway on that network, which communicates via 4G with our cloud and allows us to monitor the data in real time. Use this data to feed our model of the building, our digital twin of the building. We add on top of that, of course, our knowledge, our know-how, other data like the weather forecast, any data that is relevant from the properties of your building structure or your HVAC equipment itself. And what we give as an output is optimized parameters for each HVAC device in the building that we are therefore able to send as a command directly to the HVAC equipment, all that being done again in real time in the building. So worth mentioning again, we do not have any extra sensor. It's no hardware, and this is a pure software solution. It's basically like an upgrade of the building management system that results in very significant savings while maintaining the comfort for the occupants, which is still the main priority for us. Thanks, Zineb. You can move on. So here, I mean, I'm not going to comment too much on that, just for you to have an overview of how it works. You see at the bottom right of the left side, the thermosphere gateway. So we implement basically our gateway on this network that has all the HVAC equipment. And we see here the communication to our data lake, and then our digital twin that includes a model, controller, and QA and monitoring, plus the weather data. You can move on. So best way to illustrate what I said is a little example with a case study. So this is a project that we've run with Unibail-Rodamco Westfield in France on the shopping center Rosny 2, which is one of the top 10 largest shopping malls in France. It's over 150,000 square meters, located near Paris. Has a pretty classical setup with local production, with boilers, chillers, air handling units on several zones. We have like a huge horizontal building with 1 or 2 floors and a BACnet BMS. Can move on to the next, please, Zineb. What we did with Westfield is basically follow the very simple step-by-step installation. So first of all, and probably the most important, is talking to our clients and the tech teams in particular to determine the objectives, but also all the specificities of this particular building. The second step is the connection itself to the building with the gateway, the 4G gateway that you can see on the second picture. A little bit of IT configuration, which usually is basically done in a couple of hours, that allows us to have a proper testing of the communication between our cloud and the building itself. And last part would be testing before the deployment of the solution itself. For you to have an idea, this process altogether, in the case of Westfield, took about 3 to 4 weeks, and we were able to see the first results on the energy savings after 5 weeks. Can you please move on? So here, the results, as I mentioned, so 3 weeks of deployments, 2 weeks after that for first visible results. We control, in that case, boilers, chillers, cooling towers, pumps, and air handling units. And we achieved very significant results, so close to 30% energy savings and reduction of the CO2 footprint. And we actually did improve the comfort for the occupants. The main reason for that is that we managed to have a very constant temperature instead of having peaks, which is usually the problem with the building management systems that control the HVAC equipment. So altogether for that client, after 6 months of operations, it resulted in over 35,000 euros of cost savings, just for you to have an idea. And it came at no cost. You can move to the next one, Zineb. Since we have a commission-based pricing, in other words, we only start getting a remuneration when we deliver the first savings. There is no installation fee, and we basically share the savings between the clients and Thermosphere. Good. So I think I took enough of the time. So thank you so much, everyone, and please feel free to shoot any questions afterwards. Thank you, Zineb, and thank you for welcoming me here.
Thank you so much, Nicolas. We have a first question, actually, from Shimizu Corporation. Do you think you can provide your service even in Japan?
Yes, absolutely. So that's also, I would say, the luxury of software. We are agnostic regarding geography. The interesting thing also with our solution is that we communicate directly with the network of the building management system. And there are basically 4 or 5 communication protocols that cover 90% of the market worldwide. So that would be BACnet, Modbus, Mbus, and that would be in Japan, that would be in Europe, that would be in North America, all the same. I think the only question for us is the translation topic, but that can be solved quite easily. And we actually did run some projects in Asia already, not in Japan specifically, but it's absolutely doable for us.
Okay, and can you tell us, thank you, can you tell us what is your metric for comfort?
So the metric for comfort, we determine with the client a range of minimum and maximum temperature, which is considered as comfortable. So this is basically becoming the constraint for us that we have to always navigate between those two boundaries. The way we measure it usually is by looking at the time of building operation within this range. So in the case of a shopping center, for instance, we would look at from 9 o'clock in the morning till 9 o'clock at night, how much of the time was within those boundaries.
Okay. And do you use AI for analyzing HVAC data and the ESCO model?
So, I mean, AI is a very broad topic. So the answer is yes or no. I mean, we do not use machine learning, if that is the question. Our technology is quite specific in that sense that we use thermal modeling and thermodynamics, which means that we see the building as a physical system and we analyze the heat flows between the different thermal objects of the building. So between the walls, between the ceilings, between the windows, like the sun coming through the windows, the HVAC equipment, the humans in the building, it can be also the lighting. So when we start, when we deploy the solution in the building, we already have a canvas of the building. We already know that every building works the same way when it comes to heat flow. And that gives us a very strong competitive advantage compared to machine learning solutions where they have to learn everything from scratch. We already know it's a building. We already know there are heat transfers. We know there are some thermodynamic laws that just physics cannot avoid. And that's how we can have results so fast. And that's also why we do not need to have like a super broad range of data available in the building. We do not need to have tens of sensors or IoT. We work with whatever your building management system currently works. You have the data there. We will make it a bit of a more intelligent usage.
Okay. And do you need 3D model for of the building?
Absolutely not. I mean, we need basic information like blueprints of floor plan, HVAC diagram. This is usually what we work with. We haven't done any fancy 3D modeling so far. It would be just for the aesthetics, I would say.
Okay. Do you think it is working for other types of buildings, such as a hospital, office buildings, factory, hotels?
Absolutely. So any, I mean, there is no fixed rule on the asset type. The requirement for us is you need to have a building management system in place and you need to have the HVAC equipment connected to that building management system. In practice, what we see and what we know is that it's the case in the very vast majority of commercial buildings that are above a certain size, somewhere around 5,000 square meters. We find this type of equipment and system, and that would include, of course, office buildings, hotels, hospitals, airports, even some logistic platforms or warehouses. There is absolutely no consideration for us of the asset type. Every asset has specificities in their usage, and we take that into consideration, but it's absolutely not a decisive factor whether the solution is implementable or not.
Okay, very clear. I think it's related to the other question, what applications will it work best? Commercial, large buildings, housing, airports, I guess it's your answer to that too.
The more you're consuming, the more we can save is my answer. I think the only limitation here is residential is definitely not in the scope because usually we do not find the right equipment in residential buildings.
Okay, and one last question. Any provisions for cybersecurity?
So, I mean, regarding cybersecurity, we have pretty secured communication between the building and our cloud. To be honest, we do not manufacture the device itself. We buy it directly from Siemens. So they provide a pretty good solution regarding the data encryption, security, and we've been very satisfied on that side. Maybe one point that I can mention there is we do not take over the control of your building. You can always take over manual control locally. So as you used to do, you can deactivate our solution within one click. It takes literally 30 seconds. From that perspective, there is basically very, very limited risk in terms of security.
Thank you very much, Nicolas. We have your contact here. Do not hesitate to write it down on the chat, and our audience will be very pleased to take to contact you if they are interested. Thanks so much. And now I'm glad to welcome Michael. Thanks. To welcome Michael so that he can present to us Freeltech.
Hello, good morning, everybody. Thank you for this opportunity. I'm going to speak about the vacuum capacitor, which we are developing. We are a Luxembourg company, and what we are developing is a kind of super capacitor to become the core component of highly efficient energy storage solutions. So of course, with the applications in the building, in the building sector, as front of the meter or behind the meter solutions. You can go on, please, on the next slide. So we all know that the market is energy. The energy production is changing drastically over these last years with the high rise of intermittent renewable productions, and energy storage as a key technology to have the necessary rate of necessary percentage of renewable energy in the global mix. And forecasts give some figures like 100 terawatt hours of energy storage needed on the global grids to make them so-called net zero by 2040. And just to give you a figure, by 2030, the combined capacity of production of lithium-ion batteries in the world will hardly reach 2 or 3 terawatt hours by 2030. So making this goal extremely challenging. And if you go next slide, please. One of the key will be the supply chain with with elements like lithium, cobalt, nickel becoming big problems for those having massive plans and in deploying lithium ion. There are other challenges and limitations for the other technologies, and we believe our vacuum capacitor can meet the challenge. We've got a solution which is going to be several times cheaper than the lithium ions. Our task is 3 to 5 times, even in the longer term after 2030, and we use due to the high and very high energy density, we can reach 5 kilowatt hour or maybe 10. And higher in 1 kilogram, which is several orders of magnitude higher than a lithium ion. We use much less materials in our solution. Please go on. As I said, our vacuum capacitor which is currently under development. We are still at low TRL, and have in mind that our solution should be ready for the market not earlier than in pilot modules, and not earlier than in tool 25 and beyond. So it's really an early stage development, but with a very high with very high promises. And what we do is injecting electrons inside small volumes. You see one prototype here in my hand, and we do it in such a way that we create so-called plasmoids, high-density charge clusters. And such good results have been obtained already in the late 2010s, and we reached an energy density equivalent to more than 7 kilowatt hours per kilogram when extrapolated to the kilogram. You basically have an yes, you have a closed volume with the mix of gas inside, and you just need a cathode and an external anode to make this happen, of course, under certain algorithm we are developing. Please go on. And here is I would say the key image. You can see how our technology will be different from existing technologies and lithium ion. You see the gap up to 100 times the average lithium ion energy capacity, with also a high power density, which is characteristics from the supercapacitors. Please go on. On these slides, a few comparative features with the existing technologies, from lead acid to lithium ion. Technologies like hydrogen, of course, and fuel cells are very fashionable these times, but they have also their drawbacks. And vanadium redox flow remain expensive solutions, especially for building. It's going to be okay for large outdoor solutions on the grid, but not very good for the construction. So we are going to target a solution which is low cost, safe and reliable, and also environmental friendly on the supply chain part, which is of course also high performance. Please go on. So we've been incorporated in Luxembourg in 2017. Majority of shareholders are private individuals, and we signed a key partnership with Technip Energies in 2020, and have already made more than 1 year of tests in one of their facilities in Marseille, south of France. Further R&D is going to happen in France, but in another place, and our technology is patented in several parts of the world. Please go on. This is an overview of the team, and with the inventor, Roman Holoshenko, who comes from Russia, and we have from the early beginning of the project decided to develop the technology in Europe. And our R&D director currently is Mr. Jean-Philippe Ginestet, and he will conduct the next R&D stages. Let us go on to Yes, this is an overview of the R&D and organization structure which was in place until now when we worked at the Technip Energies facility. I guess you will circulate this presentation afterwards, so you can get more into details. Let us go on with the slides, please. So this is the short story of our projects. So from the early stage projects, when we stored about 300 watt-hour in one of such prototype, the one which was not on the left but on the right side, it was a glass volume, like a kind of vacuum diode modified for our purpose. After these patents were filed, and I entered the project much later in 2015 when I met the inventor, and we created Freeltech in 2017 in Luxembourg. Agreement with Technip Energies occurred later in 2020 after they visited our test facilities in the area of Lyon, and we started tests at Cybernetics, so the Technip Energies subsidiary, in 2020 to progressively reach better and better results. However, we are not now at the targets we want. So R&D is going on, and we see, as I say, the first pilot modules in 2020, 2024, maybe 2025. Next slide, please. Here are some figures, some images of the pictures of the tests we are conducting. This is a test bench which allows us to control the atmosphere in our prototypes and around, and the very interesting oscilloscope characteristics we get at the outside. It's an R&D which is not, I insist, is not requiring a very large amount of money like for electrochemical technologies. Next slide, please. So the roadmap for us would be to reach stable results with the required targets. So it's around 500 watt-hour in one prototype. This should happen before the middle of next year. Technology readiness level we would qualify as 4, and then we would progressively integrate these vacuum capacitors into modules and finally reach power packs, first solutions for stationary applications. With, of course, background optimization taking place all the time to improve the characteristics, the materials, etc. Next slide. So stationary applications first, because it's going to be easier to enter the market. There are less technical constraints if compared to mobility, for instance, and our technology perfectly suits for standardized solutions, and then can be scaled up to container type, more larger scale energy storage solutions. So again, the two markets would be behind the meter and front of the meter for energy producers and grid owners. I add also that yeah, we have other solution or other customers, like of course Technip Energies, who signed this agreement with us with the aim of using our technologies in a certain number of specialized field proper to their own activities. So thank you. I would stop here my presentation.
Thank you very much, Michael. Thanks for the presentation. It was very interesting. We have a first question on the chat, and of course, to our audience, do not hesitate to activate your microphones if you want to ask questions directly. The first one is, how many times can we recharge?
Well, this should be a solution, of course, in the performance on the performance side, which should be at not worse than lithium-ion and as good as supercapacitor. So our target is clearly 10,000 times plus and more.
Okay. And can you let us know a little bit more details about the energy as a service business model based on your technology?
Well, as you understand, we are not reached at this point, but one of the business model is clearly like the energy storage solution providers, the rental of energy storage modules of different sizes. But you can at the same time run yourself the energy storage capacities, and you start providing services, for instance, to the grid or to the renewable energy producers to accommodate production and use at different times of the day.
Okay, thank you.
So grid stability and so on. Mm-hmm.
All right. How many years can it be used?
Well, we very much hope that they're going to be long-lived. Again, we would compare ourselves to the lithium-ion. Supercapacitors are also very stable in time, and I think that 10 years, everything should be done that we reach at least 10 years of life duration. There is no reason intrinsically with the materials we use, the technology itself, that there is no use we cannot reach this this target.
Okay, thanks.
But again, it's as you understand, it's a very challenging, a big disruption in energy storage. It's not simple at all, and it's absolutely a new path in the way to developing high performance energy storage solution. We are absolutely different from everything done in the world. It's not electrochemical. It's also not purely supercapacitors. We do 3D and volumic energy storage, directly of electricity. Sorry.
Okay. And based on the characteristics of the vacuum capacitor, what kind of use case do you assume first?
So the first one should be, as I said, a smaller case, a smaller size stationary storage solutions, modules. You can put them in buildings, in industrial facilities, and you can use them as close to the customer, front of the meter solutions to accommodate their needs, especially if they are supplied by intermittent energy sources like renewables. But first solutions will be rather small, maybe in the 100, 200 kilowatt hours, and you can also integrate them in EV charging stations, for instance, which it's going to be a very big. They're going to be a very big need also, because you know that the network is not always suited for the large deployment of such EV charging stations. If everybody's gonna charge its car at the end of the day at the same time, it's gonna be a huge electricity appeal, and this the grid would not support this. So the charging station itself should have a buffer inside, and this is a very good opportunity to use our technology, which can cycle a lot of time, which is cheaper and which has a much higher density, so it takes less volume than lithium ion.
Okay, thank you. And compared to the other storage devices, what is the cost competitiveness of your solution?
Well, our target is really to be in the range of around, let's say, $30 per kilowatt hour when the lithium ion dreams about getting to $75 per kilowatt hour in the long run, so in 2030 or after. But we already see that tensions on the supply chain may make this ultimate goal for lithium ion out of reach. And we use much less of material and no strategic or very expensive material. This is the very good thing of our solution.
Okay. Well, thank you very much, Michael, for this presentation of Fieldtech.
Yeah, sorry, it would have been much easier for me in Russian or French, but I tried as I could. Yeah, thank you very much.
This is great. Thanks.
Thank you.
Well, I'm happy to welcome Richard, who will present us Polysolar.
Thank you very much. Yeah, thank you for having me. And I have to apologise first up. I don't think you received our presentation before.
No, but you can, yeah.
I'll share my screen now, if that's all right.
Yeah, great.
Okay, so I just want to give you a bit of background about Polysolar. So Polysolar, historically, we were founded in 2007. So I know this was for startups, but technically we are an aging startup now. Historically, we have developed building integrated photovoltaics and the structures around how those integrate with the building themselves. The idea is to allow every property and every building to become its own energy source. And to utilize as much space as physically possible to create solar power and store that energy if possible. We are mainly based in the UK, but we do supply to the rest of the world as well. Established client base over the last 15 odd years, so the likes of Shell, Network Rail, mainly again UK companies. But what we're offering is a number of different solutions at the moment, with Polysolar providing the principal contracting role, and that has come into fruition over the last 18 months, really. We're bringing all energy systems together to allow EV charging alongside battery storage, alongside solar generation as well on these sites. So this photo is of a solar carport that we developed that has cadmium telluride thin film solar glazing incorporated within a carport structure, has 50 kilowatt rapid chargers, and it has battery storage to allow that, as Michael was saying, and to allow the grid not to have any issues with surges from when people plug in their cars. So the majority of what we have historically installed is the cadmium telluride thin film product. obviously we did a lot of research on greenhouses and how the ability to allow the light through to the plants underneath and generate power for greenhouses in agrivoltaic situations. How can that then benefit plant growth and impact energy generation in the fields themselves? We are still doing a lot of R&D in that sector, but it has moved towards the energy systems and the bigger applications of how we can actually install this. So conventional PVs we do offer on the side. Monocrystalline silicon cells allow us to generate a little bit more power per meter squared, but it does create that Doppelt effect on the glass itself, because it creates those opaque cells that are embedded within glass, and then you separate those cells out to let that light through. The cadmium telluride is what we usually install for building integrated, because it doesn't have that Doppelt effect. It can be manufactured in anywhere between opaque all the way up to 80% transmissibility. Obviously, the amount of power that is generated is proportionate to the amount of light that is allowed through. So usually we don't install anything lower than 50% transmission, because it just isn't highly efficient. But if that's what you want, then we do offer that as well. And then an alternative to roof-mounted panels are the lightweight, flexible monocrystalline silicon panels themselves, and these just allow the flexibility. They're lightweight. They mean that they have a lot more applications for warehouses and factory roofs, where conventional PV just cannot be installed because of that weight element. And if there's a curvature to the building or the roof itself, then these work out, and they're 21% efficient. Our cadmium telluride technology is about 12% efficient, and the monocrystalline is around about 19% efficient. So you can get an idea of how they generate power. So yeah, we are these mainly the main benefits of solar glazing is that it has a dual-sided operation, so it does capture electricity or the sunlight from underneath the glass as well. It naturally lights up the area below, which is always quite helpful in the UK because it is quite gloomy and grey. But the other benefits are the fact that it just allows that light underneath it, and the performance at low light levels, again for the UK, is brilliant. Low light levels is better than your conventional panels. It doesn't require direct sunlight to generate electricity. When you're applying it to a building facade or the cladding of the outside of a building, obviously it gives you the main benefits of any other glazing products. The insulation values are around about a U value of around about 1 for double glazed solar glass. The G values, which is the thermal gain into buildings, is significantly reduced because it absorbs a lot of that light and heat to generate that power. And actually, to the reduction of air conditioning loads because of that thermal gain reduction can be as significant as the solar energy yield that's created from the panels themselves. Here's a couple of examples that we have installed. So the cadmium telluride is on the right there. So we did a product down in Gibraltar for a big facade project there, and the Science Park in Cambridge, we also did it, and another benefit of the having it on the vertical aspect is that when you have solar panels that are on the roof, they like having direct direct sunlight. So you have a lot of power generation in your summer months when the sun is directly overhead. If you have it on the vertical side, it actually allows you to generate a lot more power when the light or when the sun is lower in the sky. So your December, January, February months in the Northern Hemisphere allow you to have a smoother generation throughout the year, which is another added benefit for doing it on the vertical side. The development from facades and greenhouses and agrivoltaics is we've moved into solar carports. This is obviously there's a lot of space in car parks, and to generate power to charge your electric cars underneath, and to store that power in either the car's battery or an on-site battery storage system is something that is definitely developing, and that is where the growth is for Polysolar in the has been for the last 6 to 12 months and will be for the significant future. It's maximising the space. A lot of the projects that we are working on already have solar installed on their roof. They've maximised the amount of solar they can generate on roofs themselves. So they need an added space, and above the car parks is absolutely perfect for a 25-year, 30-year period of how long these are going to be lasting. And in terms of the power output, you're looking at around about 3 kilowatt peak per car parking bay, and then you have all sorts of different variants of the designs that you actually want for the carports themselves. So the O frame is probably is the one that I've already showed you on that we did for Bristol and Bath. That does incorporate our cadmium telluride technology. Most of the applications that we do, I'm sorry about it's skipping. Most of the applications we do, they don't require any light to filter through to the underside, so they just want to maximise the amount of power that is generated from the carport. So we usually install conventional solar PV, but it is possible to add any other solar elements if you do want that light underneath. And then for a domestic setting, this has come off the back of the commercial element. We have designed a modular carport with integrated EV charging and the inverter themselves. So all you need to do is run one cable from your carport to your main incomer. It makes it as easy as possible to install outside of a customer's house. Again, this can incorporate any of our glazing elements above it, and again, this is another product that we've developed ourselves. Is a domestic canopy, which can be it can be used to install in the back of someone's house rather than above their car if they have a south or north facing property. Other elements and other projects where we have installed. So this is the first Shell's first electric vehicle only charging hub in the UK, and it was a glulam beam structure, and a huge structure, and we incorporated monocrystalline silicon cells within it to generate some power for the EV chargers and the batteries underneath. Sainsbury's, we did a petrol station for them, and we actually had a different product for it was called amorphous silicon, and it created this orange tinge to the glass, which was obviously perfect for their marketing because it worked very well for the color elements. And then the flexible, I've briefly mentioned this, so I will skip over this a little bit, but the main benefit is that you still get the high efficiencies in comparison to conventional PV, and it has the ability to be installed on any roofing system wherever you are, and it doesn't need as much weight doesn't add as much weight as the conventional panels. The next thing we have moved into is battery storage systems. Obviously, this is becoming more and more pressing now with the rise of renewables. We need a way of storing excess energy generated from wind and solar and anywhere else, and then using that when the sun either goes down or the wind stops blowing. So we're getting a lot of interest now, and we are. This is probably just the start of Polysolar in batteries, but that is what we are offering a lot of our clients now. Is a fully integrated energy system to offer the full package. In regards to R&D and the glass element, we are also doing some more research into OPV, organic photovoltaics, and that will hopefully allow us to produce panels for lower cost with just as much efficiency as the cadmium telluride, and allows that light still to filter through. But unfortunately, in the UK, the facade element of our business has dropped a little bit because of rules and regulations, but that may pick up again, and and that is it. So thank you very much for listening. I will stop sharing my screen, and if there are any questions, please fire away.
Thank you very much, Kurt. Thanks for the presentation. Does anyone have any questions? Once again, activate your microphones or just write your questions on the chat. Maybe I have a first question about the countries that you have implemented your solution so far.
As I said, it's mainly the UK, but we do Gibraltar and South America. We've done some projects, and in Asia as well. We've done a little bit.
Okay, brilliant.
Great.
I think it was quite clear for everyone, and we'll have the possibility to share the presentation slides. Have you already got an interest from Japan or not?
For the flexible panels we have, but not for the cadmium telluride or the transparent solar glass, in all honesty.
Okay. I think there's a question coming. Yeah. What is your strategy to expand your solution into the other markets?
That's a good question. I think in terms of where we are at the moment as a business, there's a lot going on in the United Kingdom. We are only 8 people, so as I said earlier, the main thing we can offer for international markets at the moment is supply of the glass. We won't be and the flexible. It might change in the future, but at the moment we are going to be focusing on the UK market. I think for the next six months at least.
Okay, and regarding maybe the investment part, are you looking for investments or?
Is that what? Well, I know that Hamish was supposed to be here. I know you've spoken to him before this. We will be, yeah. We will be doing another funding round for sure.
Okay, that's good to know. Well, thank you very much, Richard.
You're welcome. Thank you very much for having me.
Yeah, thanks.
Cheers.
I think, yeah, sounds great to work in the UK market, waiting for you to come into the Japanese market soon.
Thank you. We'll be there soon.
Not so soon. Thanks so much.
Cheers.
And finally, I'm glad to welcome Michael Evans, who will present us Cambridge Carbon Capture.
Hello. As with Polysolar, I haven't sent a presentation beforehand, so apologies. So I will do a share screen.
Yeah, no worries.
So bear with me. I have many screens. Okay, so I've just got to be able to see my, there it is.
Yeah, perfect.
Yeah, so into presenter mode. Is that clear?
Yeah, it is.
Excellent. Okay. So yeah, we're Cambridge Carbon Capture, another Cambridge company as well as Polysolar. In fact, we shared offices for a while, so it's quite fun to see how they're progressing. Yeah, so we're developing a technology we've called CO2 lock technology, and this technology permanently locks CO2 away as a mineral byproduct called magnesium carbonate. And we also produce a number of sustainable critical metals, such as nickel and cobalt, used for battery technologies, and also high-value silica in the form of amorphous precipitated silica, which again is used a lot in construction and in car tire manufacturing, etc. We have an internationally granted patent, and our unique selling points are that we permanently capture and store CO2. We can do this whilst generating a profit, and because of the size of the markets that we're producing byproducts for, we can actually scale to gigaton levels quite easily. An additional advantage is that the products we produce displace carbon-intensive alternatives, such as in the construction sector. And we don't need any sort of CO2 pipelines or storage infrastructure, so we don't need any sort of deep sort of investment from governments, etc. As you're probably all aware, particularly with the most recent IPCC report, carbon capture and utilisation storage technologies are going to be a key player in our path to net zero. It's absolutely essential, in fact. We cannot reach net zero without these technologies. And you know, there's existing technologies out there available today. Carbon capture and storage is the main one. It's receiving most funding and attention. But this requires expensive infrastructure like pipelines to transport the CO2 from where it's captured. The actual capturing process itself is very energy intensive, and there's no commercial benefit whatsoever in any of that activity. You know, nobody makes any money. It involves some sort of high carbon tax in order to make the whole thing stack up commercially. So there are sort of a number of technologies that are looking at utilising the CO2 that's captured, so you don't have all the expense of the pipelines and storage. And you know, the sale of these byproducts can offset some or all of the cost, and our technology is one such technology. And there's additional benefit because the materials that are produced with the CO2 will actually displace alternatives that are in the market today. That they're actually carbon intensive in their manufacturing. So there's a double benefit. Problem is that, you know, a lot of these technologies are restricted by the size of the markets, also by the cost. I mean, particularly things like the fuels that are used are made using captured CO2 and hydrogen. You know, the overall cost is significantly higher than the sort of the carbon intensive alternatives. And also, as a solution, you know, if you're burning that fuel again, you're re-releasing that CO2. So the benefit's not really there, other than the fact that you've displaced some fossil fuels. So this is our technology. We've called it CO2 lock, and it's a two-stage process. And stage one, producing materials that are used in stage two to actually physically capture the CO2. So stage two starts, it's very similar to flue gas desulfurization technology in that, you know, there you're removing sulfur from emissions from coal burning, for instance. And a lot of power stations across Europe have this technology already installed at a very large scale. And that uses a limestone slurry and captures the sulfur to form a gypsum, which is then used in the construction material. So you can see it's very analogous to what we're proposing with our technology, in that our technology uses magnesium hydroxide in place of the limestone slurry, so exactly the same plant. And we can capture CO2, NOx and SOx using our chemistry. And the whole lot is held in a magnesium carbonate byproduct. So this is an example of some of the rock we made earlier. You see, it's quite lightweight. It's solid. It's strong-ish. Certainly on an equivalence to gypsum. It has a number of uses. Particularly interested in the construction sector. So we're working with partners in the construction sector to develop some construction materials from this, including CRH, who I believe is on the call today. We've also had some involvement with Saint-Gobain in the past as well. So we're exploring the market for this material in the construction sector. We're also using it potentially in paint, for paint bases, and also for washing products as well. So in order for stage 2 to make sense commercially, we need to ensure that we can buy magnesium hydroxide cheaper than you can sell the magnesium carbonate that's produced. And this is where our stage 1 process kicks in, because currently magnesium hydroxide sells on the market for about $1,000 a ton. So clearly it's not a viable solution today. However, we can manufacture magnesium hydroxide to below $40 a ton, which makes this very much more viable as a commercial way of capturing CO2. So we start with our stage 1 process using very abundant rocks that are basically about between 50 and 80% of the Earth's crust is made from magnesium silicates of one form or another. So the ones that we are particularly interested in because of the high magnesium content are serpentine and olivine, and asbestos waste. We can use asbestos waste potentially. And lots of these materials are actually in existing mining tailings. So we're working with the mining sector to look at their mining tailings and seeing if we can actually use these to extract magnesium hydroxide, produce silica. And the advantage of that is that we can also create quite a lot of revenues from metals that we can extract. Because normally those metals are sort of contained and trapped within the matrix of the rock. And because of the way we're digesting this process, this material, we're releasing that metal and making it available, which otherwise would not have been achievable. So even from mining tailings that have been used, all the metals have been extracted, we can extract further metals from those same materials. So when we look at the costs and the revenues of our process, in this diagram here, the costs are in red and the black shows revenues. We make a net profits per ton of CO2 sequestered of around £310. So that's what, 400 euros, thereabouts. And that's assuming a carbon price of around £50 a ton, which is more or less where it is today. So looking at the sort of applications of our technology, the most obvious one, particularly for this audience today, is CO2 stripping from power stations or industrial processes, such as cement manufacturing and steel refining, etc. So we can take any proportion of CO2 in any flue gas and remove that, whilst also removing NOx and SOx, if that was also present in the emission. Another area of very big interest for us, particularly in the UK, where we're pushing quite strongly for a hydrogen economy. Hydrogen is all good if it's coming from renewables, but the bulk of hydrogen will inevitably come from the cracking of natural gas. And that process produces CO2 in itself, which the plan is to capture that and store it, but we could also capture it and remove significant proportion of the capital equipment required within the process itself. We get rid of all the compression stages, all the drying stages, all the separation stages as well. So we remove quite a lot of the costs associated with the manufacturing of hydrogen from natural gas, and we make a sort of what they call blue hydrogen, which is not quite as nice as green, but it's still low carbon. So the other option we're looking at is cleaning up of gases. So currently we're looking at syngases produced from pyrotisation of waste, etc. Here we can remove NOx as well, which is very useful. We also take out H2S from biogas, which is the smelly and poisonous part of the gas, which you may be aware of. We can deal with that as well quite successfully. Another market we're looking at is actually materials production. If we were just looking at our technology as purely a way of producing low embedded carbon sort of construction materials, that's a market in itself. But the one that is of most interest to us at the moment is critical metals for the battery technologies. Here, because of EVs and energy storage requirements, and also what's happening with Ukraine, Russia is a major source of nickel and cobalt, and clearly, there's massive growth in demand for these materials because of electric vehicles and battery storage requirements in the future. So they need to be able to access materials that have been produced sustainably and in locations that are politically correct. So this is something that we can do, and we are actually in discussions with a number of people in Norway around the mining industry and accessing some of their minerals to extract these metals. Most recently, we've started to look at direct air capture. There's been a huge increase in interest in direct air capture, and we've discovered that our technology, with a small tweak, is very successful at this, and we believe that we can still make significant profits from the materials that we can produce with our process. So we can actually capture CO2 directly from the air anywhere in the world, because obviously the atmosphere goes everywhere, so we don't have any CO2 transport costs associated with the technology. So we can put it in mines, we can put it in deserts, anywhere where the materials and energy is available. So we currently have quite good traction. We're currently seeking grants and investor funding to support piloting of our stage 2 process with a company called Dreadnought. Dreadnought have been producing ceramic tiles in the UK for 200 years. And it's not possible for them to reach net zero. So they're facing an existential crisis unless they can find a technology that will enable them to continue operations in their community, bearing in mind that these communities have been around for many, many years. So it's not just about reaching net zero, it's about jobs within those communities and securing the community's future. So this is really quite crucial for companies that aren't anywhere close to where planned CO2 pipeline infrastructure is being put in. If you're a company that's sort of landlocked, there's not going to be any pipes coming to you in the near future that are going to allow you to transport your CO2 away. So technologies like ours are going to be crucial for those sort of industries. Most recently, we are in the process of negotiating a contract, a £3 million contract, to build a pilot plant for our direct air capture technology in Merseyside. And here we've got some really important partners, and really looking forward to starting that project maybe in May this year. So in summary, we have a circular economy solution to climate change. Our technology is easy to deploy and offers a route to profit from the permanent capturing of CO2. It has the additional benefit of creating byproducts which displace carbon-intensive alternatives in the marketplace. So there's additional carbon benefits from our technology. And there's also strong market demand due to the rapid accelerating climate change situation. And we have a very strong patent position and significant unique selling points over competing technologies. So with that, I'll end. And any questions?
Thank you very much, Michael, for this very interesting presentation. We have some questions. Let's see. First, could you tell us your stage of development, lab level, proof of concept stage, commercial level?
Okay, so I mentioned our technologies in 2 stages. So stage 2 is where we're capturing CO2 from emissions. So this is probably the most relevant to many of the audience here. We are actually at TRL 4 to 5 on this. So we currently have a design for a scrubber. We've done a feasibility study and front-end feed study of our technology in an application for Dreadnought tiles. We're also looking at applications across Europe. So we're looking at a chemical company in the Netherlands and another ceramics company in Spain. And we're currently looking for funding to support those demonstrations. Stage 1 is slightly earlier. It's at TRL 3, but we're hoping that this project that we get in to do the direct air capture will provide us with the money that we need to do a pilot for both stage 1 and stage 2 in parallel, and which will take both technologies to about TRL 5 or 6 within 2 years.
Okay, thanks. And how many members do you have?
Currently 3, about to recruit a 4th. So we're a very small team. We've been around quite some time. In fact, we were founded at a similar time to Polysolar. So
long time then.
Yeah, we share a founder actually. And I've known Hamish for many years. So yeah.
Well, he's sorry he can't be here. He's enjoying Peru at the moment.
I'm sure he is.
Okay, thank you. Have you had the opportunity to work abroad?
Yeah, we're actively seeking funding for some projects in the Netherlands and also in Spain. So yes, we're very keen to move ahead with that. We have a project that may be starting in the summer with Bangladesh. So we'll be working with the Minister for Energy there to look at how our technology would map onto their particular emissions issues. We have active conversations with Japanese corporates, and we also have active engagement in the US. So we are looking to expand. We also have some very good contacts in China. We're waiting for our technology to be at a high TRL before we're approaching that, but we have the investor infrastructure in place to tackle China once we're at that stage.
Okay. And what CO2 sources are your main target to capture?
Well, I think our unique selling point really is in the lower concentrations. The interest from the ceramics industry is because our technology can remove CO2 from very dilute sources. So typically in a kiln, because they're usually drawing in air, the CO2 is quite diluted down to around about 1%. So we're particularly good at low concentration. So that's one of the focuses. But the sweet spot is around about 10 to 12%, which is the emissions from natural gas. So that's the sort of level that we're sort of assuming that we will be working most of the time. But we can also work with 100%. So we're actually working alongside some other technology companies who are capturing CO2 as a sort of a way of dealing with their CO2 that they're capturing when they're away from any CO2 pipeline infrastructure. Okay.
And what do you think is the most valuable way to utilize the captured CO2?
Sorry, say again. The most
valuable way to use captured CO2.
Well, I mean, the actual captured CO2 is actually in this material. So some of the applications that we're exploring, there's some very easy low-hanging fruit that can get us to market quickly, such as construction blocks, because the regulation in the UK is quite relaxed around that. As long as it has the required strength, they're not too concerned about what's in it. So that will get us into markets early. Some other things we're looking at are precast concrete structures, such as paving stones, sort of street furniture, sort of barriers, and these sorts of products. Again, because they're non-structural. The issue around introducing new materials into the construction sector is that they've been using the same materials for many years. They understand it, how it works, how long it lasts. You start introducing changes into those materials, and it introduces all sorts of risks. What happens if the material ages and becomes brittle after 10 years? In 10 years' time, you're going to find buildings collapsing. So who's liable? Not me, hopefully. So we need to introduce these in a very careful way. So we can see there's a route to getting these products out at scale, which is safe. And one of the key areas of interest, incidentally, with this material, this is thermally insulating and it's fireproof. So we're currently thinking that the most useful product we can get out in the short term would be some sort of exterior wall cladding. It's also very weatherproof as well. It stays like this forever. You can wet it, you can put it in fire, you can do anything to it. It's indestructible. It doesn't like being hit by hammers, but other than that, it's fine. So you know, the fact it's lightweight, it's thermally insulating, and it's fireproof means that it's a perfect cladding material for existing buildings because it's not adding significant weight to the structure. It's fireproof, and we've seen what can happen when other insulating materials can set on fire. I don't want to be anywhere close to any of those materials if that happens. And it's completely non-toxic. You can eat this stuff. Seriously, in fact, you do. Many sort of pills that you use for medicines, they have magnesium carbonate as a base. Some mint sweets, they also have this as a base. You eat this stuff all the time, and magnesium is actually good for you. So it's something that you could consider. It's very safe.
It is good to know. Thanks. And could you maybe tell us about the strength of your concrete blocks?
Well, I mean, it depends on what you're doing, because right, this material here is literally just come straight from our process. We've dewatered it and allowed it to dry in air. You can process it in different ways and produce different forms of magnesium carbonate. So this particular version is called Nesquehonite, and it's good because it's a light open structure. If we can do it in a different format, if we dry it in a different way, we could produce magnesite, which is almost like marble, so a lot denser, a lot stronger. So there's different sort of formats that we can produce. We can also mix it with cement to form ready mix, so displacing other materials within the ready mix. And this actually is an area that we're really keen to explore, because as this material, if we put it in the form of Nesquehonite, as this material dries, it emits some CO2. And if you're aware of companies like Carbon Cure, where CO2 is used to accelerate the setting of the cement, and it's having some commercial value, it potentially could accelerate the curing of that concrete on site as well, making it much quicker to construct the buildings, and therefore much cheaper. It has the added advantage as well in ready mix that if we were using it, for instance, much concrete is used to surround the steel frameworks of the building, and the steel frame takes load. The role of the concrete is not to take the load, but to protect it in the case of a fire. Because we've all seen with the Twin Towers what happens when a fire actually gets through to the steelwork, the whole building starts to change shape and goes unstable and falls down. So in order to prevent that, that's why they clad the steel frame with concrete. If we were to clad it in this material, which is fireproof, it also absorbs a lot of energy because it goes through phase changes when you heat it. It's also lightweight. You can see that this potentially in that particular market would have significant benefits. But this is something that needs to be developed and explored. So this is why we're working with CRH, Hosen and others to develop these sort of technologies. They have the resources to do this at much bigger scale. They have the expertise and the knowledge of their particular markets. We're a small company. We can't do everything. So our idea is to collaborate very closely with supply chain partners and partners within industry as well. So it's important to collaborate. I think to use people's skills and access their funding as well to enable us to do what is. I mean, it's a very complicated thing to develop. We're developing a whole new supply chain. And this is a really big challenge, and we need to work collaboratively to do that with existing supply chain partners. So the construction sector is a case in point. The mining industry as well. They're very important partner for us, and we're working with them. We're actually working with one of the key plant manufacturers for that particular market, and also for the cement industry as well. FL Smith is a partner of ours. They're helping us to design our process to scale. They have a lot of expertise in how these things are built at very large scale. They know the operating costs and the capex costs of these sort of equipment. they're feeding that information into our models and allowing us to predict with some credibility, you know, how our technology would scale before we actually get to that scale.
Okay, thanks. And I think it quite answers to the last question. How do you expect to use concrete block in construction industry? So you, I think you have a.
Well, the answer to that is we don't. Our plan is to focus. Our commercial plan is to focus on our stage 1 technology and work with CO2 emitters to provide them with a supply of large quantities of magnesium hydroxide, which could then feed into a plant which they own. So the emitter owns the scrubbing equipment. We would license our technology to them, as well as sell them the magnesium hydroxide that they need. So the magnesium carbonate that is formed with the captured CO2 will belong to the CO2 emitter, and they would sell it to local construction partners. So that's how the money flows. So we sit at the very start, alongside the mine, making magnesium hydroxide, which we would sell to the CO2 emitters. We also make metals and silica. So this is where we make our money.
All right. Well, thank you very much. I think I can thank everyone, and especially Nicolas for presenting us Thermosphere, Michael and Eugen for presenting us Fueltech, Richard Wise for presenting us Polysolar, and finally Michael Evans for presenting us Cambridge Carbon Capture. It was really interesting, and I hope everyone learned from this session. For our next session, we can next slide, please. Yeah. Our next pitch session will, I'm just waiting. Yeah, perfect. Will take place on June 29th, and we will be talking about clean tech. So I hope you will be joining us. Thanks, everyone, and enjoy the rest of your day or your evening.
Thank you.
Thank you.
Cheers, guys.
Thank you. Thank you.
Thank you very much.